In continuation to our discussion, which is the chemical reactions, let's proceed now to the aldehyde and ketone. Aldehyde and ketone chemical reaction focuses on these two main reactions, oxidation and reduction. Aldehydes and ketones have so much in similarity, and one of them is having the carbonyl group in their structure. Carbonyl group are considered as polar. Again, the carbonyl group is a carbon and a double bonded with oxygen. So why is it that your carbonyl group is considered as polar? As shown in this structure, we could see that your carbon is consisting of a fractional positive. Your carbon-carbon band are actually considered as non-polar. Why is it? It is because, again, if this is our carbon-carbon, this is also true with our carbon having double bonds and also carbon having triple bonds. So, this carbon-carbon pairing is considered as non-polar because your carbon is consisting of, again, fractional positive, and thus they all consisting of positive, and positive. So what will happen here is that similar charge, it will not be polarized. That's why it's considered as non-polar. But since our oxygen is consisting of fractional negative, therefore their charges is different with each other. So what will happen is that those atoms consisting of different charge will be polarized. That's why it is considered as polar. Also, you have to take note that the electronegativity of oxygen is much greater than that of carbon. Hence, the carbon-oxygen bond is polarized. So for us to differentiate between the aldehyde and ketone structural properties, you have to take note that the aldehyde carbonyl group should have a hydrogen on their carbonyl group. While on the carbonyl group, they have to have two alkyl group or the R group. So in this case, since aldehyde should have at least one hydrogen in their carbonyl group, we always see aldehyde at the first or at the last on the structure, while on the ketone, we always see them at the middle structure. Combined with other functional group, aldehyde and ketone are widespread in nature. Compounds such as cinnamaldehyde, or the property that can be get in your cinnamon bark. You can also have your ketone or aldehyde in vanillin, in which it is rich in vanilla bean, or in the lemongrass, which is the Citra, or to make it more relatable, benzaldehyde, which is an aldehyde, is the main flavor compound in almonds. Aldehyde and ketones are responsible for the odor and the taste of numerous nuts and spices. Aldehydes and ketones undergo a variety of reactions that lead to many different products. The most common reactions are the oxidation-reduction, or also known as your redox reaction. First, let's have the oxidation. In the oxidation, as what we have discussed on the previous topic, oxidation is the loss of hydrogen or the gain of oxygen. That's why it's called oxidation, because it is gaining oxygen on its structure. And then, the main catalyst for this oxidation is your potassium dichromate. One thing to remember, if you are to have an oxidation, aldehydes readily undergo oxidation to carboxylic acid, while the ketones are resistant to oxidation. So here, what will happen? So in the oxidation or the aldehyde oxidation, the aldehyde gains an oxygen to where it is basically gaining from its catalyst, which is an oxidizing agent. So in in the resulting product, since the oxygen will be combined with your hydrogen, it will become your carboxylic acid. However, as you can see in the ketone, because on the ketone, there is no available hydrogen where our oxygen can be binded, therefore, there is no reaction on the oxidation for ketone. Aside from the catalyst, which is your potassium dichromate, oxidation of aldehyde or a mild oxidizing agent that can convert aldehyde to carboxylic acid is also the air that is available in the environment where we store aldehyde. That's why it is very important when you store your aldehyde to have it on a airtight container. Let's now have some exercise regarding the oxidation on our aldehyde and ketone. For example, here we have the pentanal. So what will be our resulting product? For us to know the product of our oxidation, which is the pentanal, let's draw first the pentanal structure. So pentanal, that is a 5-hydrocarbon compound. So from here, we could see that that is 5, and since this is pentanal, or the ending nal, so this is considered as aldehyde. So let's draw the carbonyl and then the hydrogen here, and then let's just complete the structure. And then draw the hydrogen atoms. So to have the oxidation, let's just have this symbol O, which is indicating that that is an oxidation reaction. And then again, this catalyst here will be bonded with our hydrogen, making it as, let's draw first the structure for us to see its product. And then again, your oxygen will be bonded to hydrogen, so that is an hydroxyl. And then our hydrogen. So let's just imagine that these lines here are your hydrogen. So since we now have a carbon double bond O, or our carbonyl, plus our OH, which is a hydroxyl, carbonyl plus a hydroxyl, as what we have discussed during our functional groups. So this is considered as carboxylic acid because it has your carboxyl group. Therefore, this is pentanoic acid. Let's have another example, formaldehyde. Formaldehyde is a common name. By the way, formaldehyde is the simplest aldehyde because it only consists of one carbon atom. It is manufactured on a large scale by the oxidation of methanol. It is manufactured in many products, specifically your formalin. Formalin that is used for preservation of biological specimens. So, what would be the product if there is an oxidation of formaldehyde? So, formaldehyde, since or also known as this is our methanol, so that is a 1 carbon atom. So to complete, let's just have this one. So this is your structure for formaldehyde. And then there should be an oxidizing agent. So again, your oxygen will be bonded with our hydrogen. So therefore, the structure now will become a carboxylic acid, or it will now become your methanoic acid, or since this is formaldehyde, a common name, let's just have a common name for carboxylic acid. So that is formic acid. Let's have another example. So 2-pentanone. So 2-pentanone, since this is a penta, therefore it's a 5-hydrocarbon. 5. And then this is unknown, so therefore this is a ketone, in which the location of the carbonyl is on carbon number 2. Basically, this is our pentanol. Again, if that is an oxidation, the oxidizing agent cannot break the ketone because there is no readily available hydrogen for the carbonyl group. Therefore, we will not be having a reaction. Several tests based on the ease with the aldehyde are oxidized have been developed for distinguishing between aldehyde and ketone for detecting the presence of aldehyde group in sugar or carbohydrates and for measuring the amount of sugar present in a solution. The most widely used of these tests are the Tollens test and Benedict's test. Tollens test is also known as your silver mirror test. It involves a solution that contains silver nitrate and ammonia in the water. When Tollens solution is added to an aldehyde, a silver ion, which is the oxidizing agent, is reduced to silver metal which deposit on the inside of the test tube forming a silver mirror, as shown in the last picture. The appearance of this silver mirror is a positive test for the presence of the aldehyde. There are some important things that you need to consider also. One is our water. Why? Because since our reagent, which is the Tollens solution, other reference have them Tollens reagent, consists of silver nitrate, ammonia in water. So therefore, the oxygen, one of the oxygen from our water will be bonded to our hydrogen. So as seen here, so from an aldehyde, using the Tollens test, it will have a carboxylic acid as its product. Another thing is that in the oxidation of our Tollens test, our silver ion, which is our catalyst, will become a silver metal. Again, from a silver ion, it will now become a silver metal. That's why in the beaker or in the test tube, we will see a metallic silver that is deposited at the side. So that is the positive result for the Tollens test, or if the chemical is having a aldehyde. Another test for the differentiation between aldehyde and ketone, we have the Benedict's test. Benedict's test is similar to the Tollens test in that a metal ion is the oxidizing agent, in which if the Tollens test is the silver ion, our Benedict's test is the copper ion. So for our reagent, we have the Benedict solution. Other reference, consider this as Benedict's reagent. So Benedict solution is consisting of copper sulfate, sodium citrate, and sodium carbonate in the water. The oxygen in the water will be bonded to our hydrogen so that it will become a carboxylic acid. In the Benedict's solution, the Benedict solution is naturally a blue solution. As seen here in the picture, this is your Benedict's solution. This is a blue color solution. And then once you add the aldehyde on the solution, it will become a brick red, indicating that it is consisting of aldehyde. But if in case, for example, the solution upon adding the chemical will not change into another color, so that indicating that could possibly a ketone or another chemical in which that is not a aldehyde. Let's now relate oxidation in the diabetes mellitus. You have to take note, diabetes has two types, diabetes mellitus and also diabetes insipidus. So the difference of them is that diabetes insipidus is usually a resulting disease from other diseases. So it could possibly liver disease, it could be a kidney disease. It's just that diabetes insipidus have this inflamed, or there is so much water that is stored in the body. However, the diabetes mellitus is the one who is having the problem in their insulin. Actually, diabetes insipidus and diabetes mellitus will have three possible most common symptoms in the diabetes. That is your polyphagia, polydipsia, and also polyuria. So when we say polyuria, so that is poly or many, and then urea, so that is urine. So polyuria just means that it is consistent urinating. And then polydipsia means constant drinking of water. And then lastly, polyphagia, in which constant eating. So what is a diabetes mellitus? To further discuss this, diabetes mellitus is a disease that involves the hormone insulin, a substance necessary to control our blood glucose level. There are two main type of diabetes mellitus. So that is diabetes type 1 and diabetes type 2. So their difference is that your diabetes type 1 is having a problem in the pancreas. So the diabetes type 1 cannot produce enough insulin. However, in the diabetes type 2, the problem there is the insulin sensitivity, in which our pancreas is actually secreting enough insulin, only that the insulin that is produced by our pancreas is not sensitive with the blood glucose. Therefore, it cannot go inside in our cells, and therefore, it cannot be broken down and used as our energy. So in the diabetes mellitus, we actually are using to test the urine of the suspected having a diabetes, could either be type 1 or type 2. If it is suspected that he or she might have a diabetes, we are testing their urine using the Benedict's test. So basically, you get the Benedict solution, and then drop by drop add the urine of the suspected patient having a diabetes mellitus. If it have a positive reaction, therefore the urine of the patient is having an aldehyde, and therefore that is considered as the patient is having a glucose on its urine. For us to be able to relate onto this one, let's try to draw what is the structure of our glucose. So the glucose is basically having a 6 carbon. So just imagine that these are your carbons. So 1, 2, 3, 4, 5, 6. So we have here the 6 carbon. And then in the last part, have it here. And then hydroxyl groups. So actually, this is the structure of your glucose. So this is your glucose. If in case in the Benedict's test, the solution become brick red, it is an indication that there is a glucose. Why? Your glucose is actually having a aldehyde in it as its structure. However, since we are now in the modern world, there is now another test in which it is more accurate compared with our Benedict's test, and that is our blood glucose test. That is basically using a machine which we call this one as glucometer. So we will just have some prick here, and then in here there is a enzyme in it. There is a dye, and then this blood here will be placed in the dye. And then an enzyme that will oxidize the glucose aldehyde group will react now to the blood. And then it will now interpret based on the increased number of the glucose in the blood. Therefore, it can now measured accurately on how many milligram per deciliter are the glucose level in our blood. The normal blood sugar level is or should be less than 140 milligram per deciliter. As the reading indicated in the picture, so the patient is basically on the normal scale. So he or she or the patient is not having a diabetes. Let's now proceed to another type of chemical reaction for aldehyde and ketone, which is the reduction. Reduction is basically a chemical reaction that adds up hydrogen to a molecule. Aldehyde and ketones are easily reduced by hydrogen gas in the presence of catalysts, which are nickel, platinum, or copper, in which it will have, by the help of our catalyst, it will have a loss of oxygen and gain of hydrogen. So basically your reduction again is the opposite of your oxidation. And then their product is alcohol. So the product for our aldehyde reduction is the primary alcohol, while the ketone is a secondary alcohol, as what our example is shown here. Again, the main important part of our reduction is the hydrogen. Then, since our aldehyde reduction will have a reaction with our hydrogen, one of the hydrogen will be bonded here, while the other hydrogen will be bonded in our oxygen after our catalyst will break the double bond. Similarly with our ketone. And since our hydroxyl is bonded to a carbon in which it is bonded to only one R group, therefore this is considered as primary. And then our hydroxyl atom here is bonded to 2 R group. Therefore, this is considered as secondary. Let's now have some exercise on a reduction. So we have here a 3-pentanone. So let's write first our 3-pentanone here. Pentanone, so that is consisting of 5 carbon. 5, and then this is 3-pentanone. So our locant for the carbonyl group is on the 3rd carbon. So here we have, and then let's just complete this by having the hydrogen atoms. And then another important thing that you need to have is your hydrogen gas. And then having our catalyst, which is your nickel. So our resulting product now will be, so your hydrogen will be bonded to our first bond, and then another will be bonded on our second bond. So this will be breakdown based on the help of our catalyst. So it will have a hydroxyl group. And then let's just complete this by adding the hydrogens on their atoms. So therefore, our resulting product is 3-pentanol. Let's have another example. So we have here a 3-methyl-butanol. So since this is a butanol, so this is a 4-carbon atom. And then this is a null, so we know that it is basically on the first or last carbon. Our carbonyl should be placed on the first or last carbon. And then the locant for our substituent, which is the methyl, is on the 3rd carbon. So we will count first here. So this is 1, 2, 3. So therefore the methyl group is here. So let's complete this with hydrogen. So it shouldn't have a bond here. And then another thing for our reactant, we need to have the hydrogen gas. And then with the help of our nickel as the catalyst, the double bond now will be broken down. Our resulting product now will be, let's write first the structure. Again, our nickel will break the double bond, having it as OH, because one hydrogen will be bonded to the oxygen, another one will be bonded to the destroyed double bond, and that become a hydrogen. And then, let's have the substituent, which is the methyl. So therefore, our resulting product now is 3-methyl-1-butanol. To summarize everything, we know that if there is an oxidation of an aldehyde, there is a resulting carboxylic acid, while on our aldehyde, if that is a reduction, there would be a product which is the primary alcohol, while on the ketone reduction, that is a secondary alcohol. However, we can also synthesize ketone using the reverse reaction of our reduction, which is the oxidation, in which if the alcohol is secondary, using the oxidation process, we can obtain the ketone, while if the alcohol is primary, we can synthesize aldehyde on the oxidation reaction, making a aldehyde.